Math 100, Lesson 10-6, Radical Equations. So for these, we are going to have problems that our directions are going to say something like solve. And our problems will look different this time because they will actually be equations, not expressions. Remember, an equation has an equal sign. Right, so this would be an example of one type of problem we'll be asked to solve. So there's two things that we need to make sure of. The first thing we need to always do is isolate the radical on one side. In this particular problem that I have here for you, it is already isolated on one side. Now when I say one side, that means of the equal sign. The next thing that we're going to do is to solve. And then finally, the last thing that is super important is we need to make sure we check our answers. In other words, we go back to the original, plug it in, and make sure that it actually works. Just like when we were doing fractions, you can't have a zero in the denominator. When we're working with radicals, we can't take the square root of something negative. So we must go back and check our answers. Okay, so let's go through how to solve this particular problem. We want to get x alone. So the first thing I've got to do is get it out from under the radical. So what I'm going to do is I am going to square both sides. In algebra, whatever you do to one side, you must do to the other. So when I square that square root, it leaves me with 3x plus 4. 8 squared is 64. And now I just have a simple algebra problem to solve. Divide by 3. So x is 20. Okay, so I've done my solve. Now to check my problem, check my answer, I'm going to go back to the original problem. I'm going to plug in that 20 and make sure that it actually works. I get the square root of 64, which is in fact 8. All right, so x does in fact equal 20 in this particular problem. Okay, so in this particular problem, I want to make sure that it is clear to you that that plus 7 is not under the radical. So the first step that I listed for you was we must isolate the radical on one side. So that plus 7 needs to move, okay, because the radical is not alone. All right, now the radical is alone. All right. So if I go through my steps of solving my equation, the next thing I would do is square both sides. I get x minus 1 is positive 25. Add 1, and I get x is 26. So now I want to go and check my answer. Go to the original problem, the original problem. Okay, so I plugged in my 26. I'm actually going to go through the arithmetic. And hopefully you notice we have a problem. 12 does not equal 2. So what that means is that x cannot equal 26. So there is no solution to this particular problem. My answer is no solution. Now I do want to point something out to you. When we got to this place before we squared both sides, here's something I want to point out to you. A square root never, ever, ever gives me a negative answer. That was enough for me to know this was a problem before I even continued to solve. But if I forget that step, if I forget to pay attention to that, it still worked out. All right, check your solution. This is why it is super important to check the answer that we get. All right, so our first step is isolate the radical. So that minus x needs to move to the other side. Now, I like for my x to come in front, so I'm going to say x plus 2. You could say 2 plus x. Either one is fine. All right. Now, to get rid of the radical, I'm going to square both sides. All right, so that gives me 6x plus 7. On the right-hand side, that gives me x plus 2 times x plus 2. I must do FOIL. Combine those like terms in the middle right there. Get x squared plus 4x plus 4. Now this 6x and 7, I'm going to move to the right-hand side of my equation. So I'm going to subtract 6x. And then I'm going to subtract 7. All right, and once we're here, now we do that wonderful thing we love, factor. All right, we are going to factor. So I'm looking for two things that multiply to be -3, my a times c. Two things that add up to be the b value, which in this case is -2. So my numbers are -3 and +1. My a value is 1 with the variable over one of the numbers I found. My a variable with the my a value is 1 with the variable over the other number I found. So my factors are x minus 3 times x plus 1. Now we set each factor equal to 0 and solve. So I get x is 3 and x is -1. Now I need to check both of those. So I'm going to check them one at a time. Okay, I'm going to go back to the original problem. I'm going to start with checking with the 3. Just doing the arithmetic. All right, and this one works out just fine. All right, so definitely x equals 3 is one of my answers. Now I'm going to check the -1. Minus negative is really a plus. And again, this one also checks out just fine. So x equals 3 and x equals -1 are both solutions to this problem. All right, these do work out to be kind of big problems the further we go. All right, so we're asked to solve. Now remember, our first step is isolate the radical on one side. Well, the problem with that is we have two radicals in this problem. So we need to isolate one of the radicals. Okay, that's still something we need to do. So I'm going to move this square root of x minus 3 to the other side. All right, so that leaves me with the square root of x plus 5 over here by itself, and then I've got 2 plus the square root of x minus 3 on this side. So we're not able to isolate both radicals, so we must isolate one of them. All right, so we've done that much. Now I'm going to square both sides. Be careful here, it's where we can make lots of mistakes. When I square the left-hand side, I do get just x plus 5. But over here, on the right, I must do FOIL, okay, distribute. All right, so I'm going to bring this x plus 5 down. So 2 times 2 plus 2 times the square root of x minus 3 plus, now I'm multiplying this, I did these two first. Now I'm going to multiply this x minus square root of x minus 3 times both of them. And I get 2 on the square root of x minus 3 plus the square root of x minus 3 squared when I multiply those last two terms. Doesn't that look beautiful? All right, so let's do some simplifying here. These two in the middle are like terms, so that would be plus 4 on the square root of x minus 3 plus this last term down here, we are taking the square root of a square, so we're left with just the x minus 3. I can combine this 4 and minus 3 to give me 1. All right. So this problem, I've done all the simplifying I can do, and I still have a radical. So here's what I'm going to do next. I am going to move this 1 and this x to the other side, because now I'm going to isolate that radical. Okay, so I'm going to subtract 1 and I'm going to subtract x. That would give me 4 on the left hand side, because x minus x is 0. All right, the radical is almost isolated, but it's got that 4 sitting in front of it being multiplied. So now I'm going to divide both sides of my equation by 4. Now my radical is completely isolated. There's nothing on the outside of the radical. So I square both sides again. And I get x is 4. So before I can say yes for sure that is my answer, I do need to plug it into the original formula and make sure that it works. So I went all the way back up to the original problem, and I put 4 where there was an x. And it did work out. So x is definitely 4. So just have to be careful when you're doing these problems. Okay, I've got one last example that I want to show you. All right. Now, this particular problem, I could actually do it 2 different ways. I'm going to come over here to the right, and I am going to rewrite what this problem says. This problem really says this. Okay, Okay, remember we've worked with fraction exponents, rational exponents, and that 1/3 means the cube root of. So I could rewrite my problem to look like what I have done over here in blue. And now you can solve this problem either using what I have written in black or using what I have written in blue. I'm going to continue. I'll do both, just so you can see the difference in the work for each one. Either way, the radical needs to be isolated, so I need to move that 3 to the other side. So I end up with -3. All right. So on this one, we do the same thing. We isolate the radical. All right. Now, I think it's clear to you for the blue, maybe it's clear, what you should do to both sides. We're not going to square both sides this time. Okay. We are going to raise it to the 3rd power. Okay, if we've got a cube root, I need to cube both sides, which is the same thing that I would do over here. I would cube both sides. Just want to show you it works no matter what my notation looks like. All right, so on the blue side over here, when I cube a cube root, I'm just left with that 2x minus 3. It's up under there. -3 cubed is -27. So let's add this 3 and divide by 2. So I get x is -12. Now I am going to check it, but I'm going to do this, show you what it looks like over here. When I multiply this, when I have a power raised to a power, I multiply the exponents. So 1/3 times 3 would give me 1. So I would just have 2x minus 3 equals -27. Notice that these two are the exact same thing. Okay, so if you want to make it look like a radical, that's fine. If you want to leave it as a rational exponent, that's fine. Whichever your mind understands the best. And if I solve this, obviously I'm going to get x equals -12. So now I'm going to check my answer and make sure that that x can equal -12. So I go back to the original problem. All right, and so I get -24 minus 3, which is -27. And now you must recognize that rational exponent really means the cube root of -27, which is -3. And so this does work out. I end up with 0 equals 0. So, in fact, x is -12. Now, here's a big mistake that I see people make. I see people in my math lab type in 0 is the solution. 0 is not the solution. The solution is x equals -12. If I go up here to the problem that we did just before, and we had to check to make sure that 4 was our answer, we plugged it in. You know what I see people do? I see people in my math lab type in things like, oh, x equals 2, because we got this 2 down here when we checked. That is not the solution. The solution is x equals 4. So be careful, just be mindful when you're typing your answers into my math lab. Make sure that you type in the answer that you got, not the number you got when you were checking the answer. All right, that is all for section 6.